Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss closed packet structure. Closed packed structure. PACKED. Closed packed structure. Last class I have discussed primitive cubic unit cell. In that I have discussed three structure I discussed, that is the under the primitive cubic unit cell. First was open structure, second was a space filling structure, and third was actual portion of atoms belonging to one unit cell. After that I had discussed body centered cubic unit cell, BCC, body centered cubic unit cell, and also I discussed face centered cubic unit cell, FCC, BCC and FCC. FCC, face centered cubic unit cell. In that we have calculated total number of atoms per unit cell in BCC, and also total number of atoms per unit cell in FCC. I have calculated. Now I am going to discuss this I am going to discuss now closed packed structure. Closed packed structure, and about this already I have briefed. That is the arrangement of atoms. I have briefed. Now I am going in details. In solids, the constituent particles are close packed, leaving the minimum vacant space. Now consider the constituent particles as identical hard sphere and build up the three-dimensional structure in three steps. Okay, just to consider atom as a hard sphere and build up the three-dimensional structure in three steps. What are the three steps? Then first is close packing in one dimension. Second is close packing in two dimension. And third is close packing in three dimension. These are the major three things I am going to discuss today. First, in three steps. Then what are the three steps? First is close packing in one dimension. Second is close packing in two dimension, and third is close packing in three dimensions. First I will discuss these three. Okay, all are arrangement. Already last class I have briefed about the arrangement in one dimension. Now again just I will go little details. First step, you have to build up three-dimensional structure. You have to make up three-dimensional structure. Okay, in three steps. Okay, and here that atom you consider as identical hard sphere. A sphere means atom. All atoms are identical. You have to consider like that. Then now first step I am telling you, close packing in one dimension. It is very easy. This is arrangement. There is only one way of arranging spheres in one dimensional close packed structure. Only one way, very easy way, that is to arrange them in a row and touching each other. Touching each other, just like you take a ball, a small ball, very small ball, okay, and 5, 6 you can take, 5, 6, maximum 10 you can keep, and just to arrange it, touching to each other in one row, This is the one dimensional, all will touch to each other. Suppose 10 you have taken, then 10 just you arrange it in one row and all should touch it. Okay, then this is actually this is the arrangement in you can say one dimension, correct? Here only one way, there is only one way of arranging spheres in one dimensional closed packed structure. Closed packed because all are touching, that's why closed packed structure, that is to arrange them in a row and touching each other. Okay, I will try to send some diagrams. Just very simple, all ball just you arrange in one row, also touch it. Just like you people are just in school, you see children will just stand one by just in one row, but they are making distance. Here you have to not make distance, also touch to each other, and that is the one way of arrangement. This is one dimension. In this arrangement, each sphere is in contact with two of its neighbors. If you think any one in the middle, then one will be in the front, one will be in the back side. Okay, means there are three, all three are in contact. One in the front, one in the back. In this arrangement, each sphere is in contact with two of its neighbors. The number of nearest neighbors of a particle is called its coordination number. Question is asked, what is the coordination number? Then what is the coordination number? The number of nearest neighbors of a particle is called its coordination number. Thus, in one-dimensional closed packed arrangement, the coordination number is 2. One in the front, other is in the back. Okay. Then in neighbor, only 2 are there. Then this 2 is the coordination number. Okay. In one-dimensional closed packed arrangement, the coordination number is 2. Correct? Because that one is in the front, other in the back. The number of nearest neighbors of a particle is called the coordination number. One way I told you, first step is over. Second step, again you can understand, already I briefed it in the last class. Now second step is close packing. Close packing in two-dimensional. In two-dimensional means length and breadth. Both sides you have to arrange. Means 3 or 4 rows. Just you can arrange the atoms. Okay, suppose 4 rows you have arranged. Same way, all are touching to each other. All atoms are touching to each other. Then that is called close packing in two dimensions. Two-dimensional close packed structures can be generated by stacking. Stacking means placing the rows of close packed sphere. Okay, this can be done in two different ways. This also I have discussed last class. First way, under this this close packing in two-dimensional, there are two ways. Okay, two different ways are there. Then first, that all should touch to each other. suppose one row is there, same way other row. Suppose a 5 sphere you have put, first 5 or 7, whatever way. Then another row again 7, third row again 7, fourth row again 7, correct? Then 7 into 4, 7 into 4 you can tell. Say that because 7 rows you have put, then 7 that is a lengthwise and 4 you consider as a breadthwise. Okay. Then all are touching to each other. And head on. All are arranged head on. Means same type arrangement. Means suppose all are touching to each other first row, that is the A type. Again same base, second row also all are touching head on head all. Third also, second also A type, third also A type, fourth also A type. Means all are same way arranged, 4 rows. 7 sphere you have taken, in one row 7 spheres are there. Like that way 4 are there and all are touching to each other head on. Okay. Then obviously you will see, if you will see the diagram arrangement, they will find that this between each four in the middle one gap is there. Because suppose 7 are there, 7 rows, and in one row 7 spheres, second row also 7, third also 7, fourth also 7. Then you will find that between the each four one gap is there, hole is there, that is called void. Okay, this is the one way for arrangement. Okay, then here I told you that this arrangement means close packing in 2-dimensional, 2 different ways are there. Then the first means the second rows may be placed in contact with the first row. Can be placed in contact with the first one such that the spheres of the second row are exactly above those of the first row. The spheres of the 2 rows are aligned horizontally as well as vertically. All spheres, the spheres, suppose first 2 rows you have considered, 2 rows. The spheres of the 2 rows are aligned horizontally as well as vertically. Okay. If we call the first row as A type, now the second row being exactly the same as the first one is also of A type. 2 rows both are of A type. Similarly, we may place more rows to obtain A type. Means 3 rows, A. Fourth also you can put. Okay, then all are A like that. But now you consider, suppose 3 rows are there, then we may place more rows to obtain A type of arrangement. Okay, I will try to send the diagram also. It is easy. Now second way, in that I told you 2 ways. The first way just you have arranged first row, second row, same way arrangement, A type. Now second type, in that here I told you yesterday also, last class I have discussed that now second arrangement will be little different. A type you have arranged, A type, A row you have arranged. Now actually second row, what you will do here, that between the 2 sphere, now we will keep 1 sphere. Between the 2 sphere, above the 2 sphere, you can keep one sphere. Then in the middle one gap will be there. Between the two sphere, upside we kept one sphere. Then obviously that one gap will be there. Total became 3. Then in the middle one gap will be there. Like that way, suppose in the first row 7 sphere was there. Then like that way, again you can keep between the two one more sphere you can keep upside. Again between the two, again you can keep one sphere upside. Then now you are keeping a sphere between the two sphere upside. Hence this arrangement will be different, B type. This arrangement will be B type. Okay, but here also all second row also all are touching to each other. But you have started with keeping between the I can say two first row 2 sphere, above that you have started keeping above that. Above the 2 sphere gap was there, on that gap you have started keeping. Then that's why now this became a new arrangement. Then this is called A, and above A you have put another as you can say other spheres, then that is called B arrangement, because arrangement is little different, B type. Again you can repeat on the B type, again A type arrangement you can do. Directly you can say above the B you can write A, just like A, you can arrange it, also to touch. Again after that, above that, again you can B type arrangement you can do. Correct? Then here you can arrange spheres in different way in comparison to the first way. Okay. Then there are two ways. Then this is because here length and breadth both are there. That's why it is called two-dimensional. Then now you will find in this two first arrangement A type. In that if you will see, they will find that any four sphere, if you will see, and their center is joined. Okay, total 4 not 5 you can tell, 5, then 5th you can keep in the middle, then other 2 will be in the corner, 2 to 4 will be in the corner, 1 will be in the middle. Obviously you will see, if the diagram you will see, then you will find that out of 5, 5th one will be in the middle, just like a square. It is making a square, but in a square one sphere is there. Means total 5 sphere is there, then 1 is in the middle and other 4 is in the corner. It is making a just like a square. Then this is called a square close packing. Okay, because it is making between the square one sphere is there, total 5. And in the second arrangement, if you will see, then you will find that now here 2 to 4, 6. That 6 sphere if you will consider, then between the 6, one sphere will be there, 7th. 7th will be in the middle, in the center. Then between the 6 sphere, in the middle one sphere is there, 7th. And if you will join all centers of a sphere, if you will join, then it will form hexagonal. Okay, 6. And here in the first case, it was making a square, total 4. Then that's why it was called a square closed packing. And second, it is 6 hexagonal. That's why it is called hexagonal closed packing of spheres in 2 dimensions. Both are in 2 dimensions. Okay, you can mark it also with red. If in paper you are making diagram, then just in a red you can make mark center. Now you take 6 center and join it by the you can say each center you just join it. It will take just like a benzene ring structure, like that way. 6 will be there, 6 side. Now that is the hexagonal closed packing. Hexagonal closed packing. And first was called a square closed packing because it is making a square shape. First case and second case hexagonal. Okay, this I have told you in 2 dimensions. Again you learn little more that already I discussed, but I am telling you a little more. In this arrangement, means second dimension only, 2 I discussed now in same way, only in that I am talking about, continuing. In this arrangement, each sphere is in contact with 4 of its neighbors. Thus, the 2-dimensional coordination number is 4. Because in the middle square you consider, a square inside one was there, one sphere. Then this sphere is in contact with 4 neighbors sphere. That's why its coordination number is 4. Coordination number is 4. In 1 dimension it was 2. Now here that in a square, between the square one sphere was there. Then that central, or you can say in center, that sphere is touching 4 neighboring. This 4 neighboring spheres it is touching. That's why its coordination number is 4. Also, if the center of these 4 you can say immediate neighbors spheres are joined, a square is formed. Hence this packing is called a square closed packing in 2 dimension. Question is asked. Coordination number also, and what is the square closed packing in 2 dimension? Question is asked. Now again I am coming to little more about the second wedge, what I discussed. The second row may be placed above the first row. Already I told you. The second row may be placed above the first one in a staggered manner, such that its sphere fit in the depression of the first row. Means gap. Depression means gap was there in that is called depression. Then the second row may be placed above the first one in a staggered manner, such that its sphere fit in the depression of the first row. If the arrangement of spheres in the first row is called A type, the one in the second row is different and may be called B type. When the third row is placed adjacent to the second in a staggered manner, its spheres are aligned with those of the first layer. Hence, this layer is also of A type. The spheres of similarly placed, that is the fourth row, will be aligned with those of second row, B type. Means first A, second B, again A, third A, then fourth B. Okay. And this arrangement is of A, B type. A, B, above B, A, again above that A. That's why it is called A, B type. In this arrangement, there is a less less free space, and this packing is more efficient. Here in AB, in this arrangement, that gap is less free space. In this arrangement, that here in comparison to the square, here you will find less free space, and this packing is more efficient than a square closed packing. Each sphere is in contact with 6 of its neighbors. Just like in a square, you have seen in the middle of a square, one sphere was there. It was touching 4. Then coordination number was 4. Now here you will find then in the middle, in the hexagonal middle, one sphere is there. That is touching with 6 of the neighbors, and that two-dimensional coordination number is 6 in this case, because it is touching with 6 neighbors, spheres, hence coordination number is 6. Two-dimensional coordination number is 6 in case of hexagonal. Okay, hexagonal close packing, hexagonal close packing of squares, spheres, not a square, spheres in 2 dimension. Okay, this I have told you. Okay, now this third one I am going to tell you. One more thing before going to the third one. Already I have discussed last class that there are triangular in shape. Here what you will find that this packing is called two-dimensional hexagonal closed packing, and it can be seen in diagram. If you will see, then you will find particularly in second I am talking about, second diagram, second arrangement, that in this layer there are some voids, gap, empty space. These are triangular in shape. These are, you will see that now some gap is there, that is in a triangular shape. That is called, that there they will find there are triangular in shape. This gap is, void is, empty space. These are in triangular in shape. The triangular voids are of 2 different types. This also I discussed in the last class. These triangular voids are of 2 different types. In one row, the apex of the triangles are pointing upwards. Apex of the triangles are pointing upwards in one case, and in the next layer, in one layer upward. Apex of the triangles are pointing upward, and in the next layer downward. Apex is you can say pointing downward. Okay, then there are these triangles have apex as 1. In one case, in one layer upward, pointing upward, and in the second layer it is pointing downward. Okay, then 2 ways I have told you. Now means first close packing in 1 dimension I discussed. After that close packing in 2 dimension I discussed. In that also 2 ways was there, 2 arrangement was there. Now third arrangement, that is the close packing in 3 dimensions. Close packing in 3 dimensions. Here actually all things are easy. If you will see the diagram, or if you will imagine, all things will be easy. Okay, I told you that in a diagram you will understand, but not very clear cut. But if you will imagine in a space arrangement, you will imagine a space that you can see from every side. You can see from the down also, you can see left side, right side, upside, if you are in a position to see, then easily you can understand. But then for this you have to imagine. Then now I am talking about close packing in 3 dimensions. All real structures are 3-dimensional structure. This is the first important point. If you will see any crystal, any solid, then in real practice you have seen that length will be there, breadth will be there, thickness will be also there. Any stone you can take example, bricks you can take examples. Length is there, breadth is there, height is there, thickness. Then all crystal is the same type. Their structure is different, but you will find length, breadth, height. Okay. Then you consider that in a space that structure, brick structure you have seen, and quickly you can understand. Down also it will keep upside, you can see down also, up also, left, right, everywhere you can see. Then every crystal structure you can you think that you are holding in a hand, correct? And then you are seeing the structure. Like that way you have to think, your imagination you have to do. Then quickly you will understand without any problem. Any crystal, whatever structure is there, whatever type, just to think that it is hanging in air, like that way, imagine. And then all structure, angles, all things you can understand. Sides, which side is more, which side is less. A stone you see that a stone is not of a fixed type, maybe bigger, smaller, shape may be different. Then like that way, crystal structure is there. But crystal is small, that stone is big, but similarity is there. Then now I am telling this only, close packing in 3 dimensions. All real structures are 3-dimensional structures. They can be obtained by placing 2-dimensional layers one above the other. Means first layer, after that second layer, after that third layer, after that fourth layer, fifth layer, like that way. One above the other. In the last, I can say, already we have previously we have discussed, that is the close packing in 2 dimensions. We have just now I discussed. Now this can be of 2 types, that also you know, a square close packed and hexagonal close packed. Okay. Then this 1 and 2-dimensional, you now think 2-dimensional length and breadth, correct? That in one case it was a square, other was hexagonal, correct? A square close packed and hexagonal close packed. Now you consider these 2, then it is very easy. What you have to do, that now in first case you have considered that A, all are A type, A type, and in other structure it was A, B type, correct? Then suppose it was only length and breadth, height you have not done, height you have that above that you have not done, only all were closed. Now what you have to do, same you can say on the length and breadth, only one spare row was there. Now above this layer, first layer, second layer you consider same way, A type. Now just to consider that with the first layer, second layer you have kept, third layer, fourth layer, fifth layer, correct? Then height will be there. Then this is the A type, A type. Then only height has increased. Then this type of a structure you will find in real life or in real structure, whatever you see, then height you will get. Then this is A type, A type, correct? Just height is increasing, arrangement is the same. Now second A, B, that is the only first layer. This is called first layer. Now above that second layer, again above that third layer, again above that fourth layer, Same type of arrangement you can do. A, B, A, B. This is the first layer. Again after that you arrange A, B, A, B. Again third layer. Again fourth layer, fifth layer. Then again you will find two types of arrangement, but in 3 dimension. But now it is in 3 dimension because height is increasing. Correct? I will try to send this structure also, but you can imagine. Imagination is far better by seeing the diagram. Correct? But I will send because in this examination you have to make sometimes you have to make a diagram also in class university examination. Okay. Then now this I have discussed. Okay. 3-dimensional. Then here 2 cases are there in 3-dimensional. Obviously you know that 2-dimensional again there will be 2 cases. Already I briefed you now. Then now again details you know. 3-dimensional close packing from 2-dimensional square close packed structure. Same way packed this square close packed structure was there. In that only you arrange it second layer, third layer, fourth layer upside, one above the others. Then you will get, you can say, 3-dimensional close packing from 2-dimensional square close packed structure or lattice layers. While placing the second square close packed layer above the first, we follow the same rule that was followed when one row was placed adjacent to others. The second layer is placed over the first layer such that the spheres of the upper layers are exactly above those of the first layer. In this case or in this arrangement, spheres of both the layers are perfectly aligned horizontally as well as vertically. Okay, in diagram I think will be clear. Means one above the other, all are just what was the first layer and the second layer also same way, third layer also the same way, all are aligned, means horizontally and vertically. Okay, similarly we may place more layers one above the other. If the arrangement of spheres in the first layer is called A type, all the layers have the same arrangement. Thus this lattice has A type only. A type pattern you will get. Okay, that is the case of a square. In the case of a square. Now come to the hexagonal. Then here I will come to the hexagonal, but here square only I am telling you. The lattice thus generated is the simple cubic lattice. After A type only I am telling you, if we will arrange, then it will become cubic lattice. Length, breadth, height all will be equal. You can make it cubic lattice. Length, breadth, height all are same. Then this the lattice thus generated is the simple cubic lattice, and its unit cell is the primitive cubic unit. And this unit cell, what you will tell, what type of unit cell? Then primitive cubic unit cell. Okay. Now I am going to tell another these things, another type hexagonal. In that case, 3-dimensional close packing from 2-dimensional hexagonal close packed layers. From means starting is 2-dimensional hexagonal close packed layers. But here now you are understanding what will be done. Same way what is arranged in the first layer, same way you arrange the second layer, third layer, fourth layer, like that way, correct? But here A, B, A, B, A, B type is there, A, B, A, B, A, B type, correct? Then here obviously, here again height will be generated. Then here again you can tell 3-dimensional close packed structure can be generated by placing layers one above the one over the other, correct? You can understand better that in a practical way that what will be the structure you can understand. Hexagonal, that way first layer, a length and breadth, that is a 2-dimensional. On that you are creating third dimension by keeping other layer above this, correct na? 3, 4 layer, 5 layer you can keep upside, then that will create new type of, you can say, arrangement. And this is again 3-dimensional close packing from 2-dimensional hexagonal close packed layers. Then 3-dimensional close packed structures can be generated by placing layers one over the others, correct? Then this I have told you, and this in diagram also you can understand, okay? By diagram also you can understand. Then placing second layer over the first layer, okay? Here little more I am telling you that placing second layer over the first layer. Let us take a 2-dimensional hexagonal close packed layer A and these things, this close packed layers A, and place a similar layers above it, such that the spheres of the second layer are placed in the depression of the first layer. What I discussed same way. Since the spheres of the two layers are aligned differently, not directly, differently, then let us call the second layer as B. Then it can be observed, if you see this arrangement, then you will find that not all the triangular voids of the first layer are covered by the spheres of the second layer. You will find it is not fully covered. In the first layer, what some void was there, empty space was there, that is not fully covered, okay? By observation, by seeing you can tell. Then this means here not all the triangular voids of the first layer are covered by the spheres of the second layer. This gives rise to different arrangement. Whenever a sphere of the second layer is above the void of the first layer, also called vice versa also, a tetrahedral void is formed. Again you listen, whenever a sphere of the second layer is above the void of the first layer, a tetragonal void is formed. These voids are called tetrahedral voids because a tetrahedral is formed when the center of these four spheres are joined. Means after keeping all the things one above the other in the hexagonal cases, then you will find if a four sphere, any four sphere you will take, then you will find that that it is taking a shape of tetragonal. Tetrahedral shape it will take, because in the middle one sphere will be there. In the middle one sphere will be there, just tetragonal structure. You have seen that carbon has tetrahedral structure, you know. 4 corner and one will be upside. You can make it, you can join it all. And like that type of situation is there. That's why it is called tetrahedral. Tetrahedral structure is formed when the centers of these 4 squares are joined. They have actually this here you can see, for the tetrahedral term T is used, correct. And what is another things, here 2 types of this will be formed, shape. 2 types of shape will be formed. It's tetrahedral. I told you, whenever a sphere of the second layer is above the void of the first layer, a tetrahedral void is formed, and these are called tetrahedral voids, because tetrahedron is formed when the centers of these 4 spheres are joined. They have this it is shown in diagram. Generally it will show by T. T means tetrahedron, and one such void has been you can say formed, that is a T. Other also is possible. One different type of void is also formed, that is a octahedral, O. It is shown by O, octahedral. 2 type of void is formed, one tetrahedral and other is octahedral. Then here this for your understanding I am telling you, tetrahedral whole, how will you understand? Then now you take 3 sphere. This I am talking about now void. How will you understand in a practical way? Tetrahedral whole I am telling you. Then tetra means 4. Tetra means 4. Then 3 sphere you take and just keep it closed. Then obviously you will find in the middle one, this void is there, empty space is there. Between the 3 sphere, if you will keep it closed, then you will find in the middle one gap is there. That is called empty space or void. Now, on this hole, above this hole, 1 sphere you put, fourth sphere you put. Then now it is covered. That space you can't see. That space you can't see, because 3 sphere, between the 3 sphere, 1 hole was there. On that hole you put 1 more. Now it became total 4. Then that hole, then there are total sphere, 3 down, 1 up. Then that hole actually, that is called tetrahedral hole. 3 sphere is joined. Then in the middle gap is there. That is actually a hole. And above that you can keep 1 sphere. Then become total 4. Then that is called actually tetrahedral hole, because that is due to the 4 sphere. And this I have told you. And this again you can understand, just like a tetrahedron structure you have seen, that 3 is there and 4th one is upside. 4th one is upside and join it. 3 point, make a triangle, and in the middle, upside you suppose, center you have taken suppose 1 particle is in the center. Then join upside. It will become just like a prism. Then all 3 points joined with the middle, which suppose 1 particle is in the middle. Then it become just like a prism like that, or you can say that is called tetrahedron shape. Okay. Then now this one more I am telling you. I already discussed about the tetrahedral and octahedral voids. Then octahedral voids I will tell you. Tetrahedral I told you. And by a practical way, what I told you, that way you can understand. Then now that octahedral voids I will tell you. Okay. How will you understand the these things? Octahedral hole. Octa means 6. Octahedral means 6 sphere, 6 atoms, 6 spheres. Then how will you understand these things? Then see, by a sphere, by diagram, it is very difficult to understand. Even I will send the diagram, I will try to send, but it is not very helpful. But we have to see the diagram for that purpose. I will send. But for understanding purpose, now I am telling you. See, you take 3 sphere. You take 3 sphere. Then obviously one hole will be there, empty space and void, already discussed, will be there. Now again you take 3 more sphere. 3 more spheres, and that you just keep on the above. Above this 3 sphere, first layer, second layer you put 3 sphere, you keep on that. Then what will happen? That gap you can't see. That gap you can't see. 3 is down, 3 is up. 3 is down, 3 is up. Then what will happen? You should put in such a way that 3 layers you can put other layer, other 3 are keeping above first one. Then what will happen? Total 6 sphere, and their gap will be there. One gap will be obviously there. One gap will be there because 3 sphere down, 3 sphere up. Then in the middle gap is there. That gap actually is called a hole, octahedral hole. Octahedral hole. Okay. Then you can just imagine 3 layers down, 3 sphere down, 3 here just above it. Okay. And now in second structure you can see both are touching. Both are touching to each other. Correct? If both will touch, then you can't see that hole. Only from the upside you can see, if it is common. Then this I tell 2 ways you can say. Third way also you can show same structure octahedral. Then it will take general octahedral structure is there, that just like you can say 4 will be upside and 4 will be, or you can tell 3 triangle. 1 triangle upside, 1 triangle down. 1 triangle in a octahedral structure, same octahedral structure. Triangle form 1 triangle upside and other triangle down. Like that way general octahedral structure will be like this. Okay, same way. Then this I have told you about the three-dimensional arrangement. Three-dimensional arrangement. That one here you will getting 2 voids, one tetrahedral void and other octahedral void. Then this is actually 3-dimensional close packing. Touching, now all are touching to each other. That's why you're telling close packing. 3-dimensional close packing from two you can say dimensional hexagonal close packed layers. Okay, from the 2-dimensional you are making 3-dimensional. This I have told you. Now this what little details I will tell you, and that after that I will stop. That only in this only in a case of hexagonal I am talking about, that is 3-dimensional. At other places, the triangular voids in the second layer are above the triangular voids in the first layer. Here you have to understand. Okay. The triangular voids in the second layer are above the triangular voids in the first layer, and the triangular shapes of these do not overlap. Okay. One of them has the apex of the triangle pointing upwards and the other downwards. This is the different. Okay, because this is you are talking about A B type. Okay, already I told you. Then these voids have been marked as O. There are two O. O means octahedral. Such voids are surrounded by 6 spheres. That's why it is octahedral, and are called octahedral voids. Question is asked. One such void, already I discussed. The number of these two types of voids means tetragonal and octahedral. Both are related. That depends upon the number of close packed sphere. The number of these two types of voids, how many number will be there in this arrangement? In the arrangement, how many these two types of voids will be there? Voids. Then the number of these two types of voids depends upon the number of close packed sphere. Number of close packed sphere, on that number it depends. And how both are related? This O and T, tetrahedral void, and this octahedral, how both are related? Then the number of octahedral voids, now suppose the number of close packed spheres be n. N may be 10, 20, 30, 100, 200, 500, any value. Just you consider n, capital N. Then suppose the number of close packed spheres be n, capital N. Then the number of octahedral voids generated will be same, n only, capital N, same number. And the number of tetrahedral voids will be double, means 2n. This question is asked. Then now today I am stopping only here. Now B type is there, placing these things, placing third layer over the second layer. Now I told first layer above the first layer, second layer I have considered. But now you know third layer also is possible. Then that I will discuss. That is also 3-dimensional. Only length will, this height will be more. Then this placing third layer over the second layer, in case of hexagonal only I am telling you, A B type, I will discuss in the next class. Okay. Thank you.